Good afternoon. This is Professor David J. Vilos Reyes. I will be replacing the lesson number 77 that was done yesterday. It was blurred. So I will be replacing by a more, that the brightness will be okay today. Okay. I check the brightness and it will be fine. Okay, thank you. Lesson number 77 under my channel Integral Calculus. Under my channel, the topic for the meantime is Integral Calculus, subtopic volume, under the method hollow cylinder washer method. And the discussion for this afternoon will be application problems. Hollow circular washer. Okay? Is it a hollow circular washer? Yeah, it's a hollow circular washer. Hollow circular washer. It's a washer. We got an opening at the middle. Okay, I will try to read the problem. The problem was the same as yesterday. So actually, I removed already the lesson 77 from the previous one because it was very blurred. You cannot see it. If your computer or cell phone is no good, or you cannot see the writing on the board. Okay, I will try to read the problem. Find the volume of the upper area bounded by the equation x minus 5 quantity square plus y minus 6 quantity square equal to 9. And the straight line is, the equation is y is equal to x plus 1 when rotated along the x-axis. Okay, I will try to give a brief summary. If we try to plot the graph of the two given equations, the first one is actually a circle, and the second one is actually a straight line. Okay? But the requirement for us to solve this problem is that number one is to solve first for the so-called intersection. Solve for the intersection. Or shall we go plotting the graph first? Okay, let's plot the graph first, so we could visualize where the intersections are. If we plot the graphs, okay, we will bring out the first equation. X minus 5 quantity square plus y minus 6 quantity square equal to 3 square. This is similar to the form x minus h quantity square plus y minus k quantity square equal to r square. From analytic geometry, that is a circle. It is an equation of a circle with center at hk, and the right hand side will be the radius quantity square. So actually, if we try to compare this one, h is actually 5, okay, and k is actually 6, so this is 6. The location of the center of the circle is at location 5 and 6, and the radius is 3. Y-axis, x-axis, the location of the center of the circle is 1, 2, 3, 4, 5. Okay, 5 measured horizontally, then 6 measured vertically. So this is 1, 2, 3, 4, 5, 6. So this is actually the center of the circle. Okay, I am just repeating what I have done yesterday. Okay, then the radius is 3. So this is 1 unit, 2 unit, 3 unit, 1, 2, 3, 1, 2, 3, this is 1, 2, 3. So actually when we connect the points, it is a circle. And the equation of that one is this one. Okay. Second one, we try to plot the straight line. The straight line is actually y is equal to x plus 1. It's easy to plot a straight line. Okay, just pinpoint the location where the straight line passes through the y-axis and the location where the straight line passes through the x-axis. So what we'll do, it will be something like this. When x is 0, y is equal to 1, meaning when x is 0, okay, y is 1 unit. So actually, the straight line passes here. And when we reverse this equation, when y is 0, what will be x? X is actually equal to minus 1. When y is 0, compute for x, x will be minus 1. When y is 0, x is minus 1, it is this. Okay? So, you just get your slide rule, straight edge slide rule, you connect this one, okay? Then you draw the straight line. So actually, this is the straight line. And the equation of this is actually y is equal to x plus 1. So as you will see, the circle and the straight line actually intersects. There is an intersection whether we like it or not. This is the first intersection, and this is the second intersection. Then we will try to compute for that intersection. Why we need to compute? Later on, we will integrate, we need limits, okay? Okay, solving for the intersections now. The first equation is x minus 5 quantity square, y minus 6 quantity square equal to 9. Equation number 1, it is a circle, y is equal to x plus 1, it is a straight line. This is just pure algebra. You put y to be equal to x plus 1 back here. Okay? What will come out will be a quadratic equation. I will not give you the complete solution of that one, but if we try to substitute y equal to x plus 1 back here, what will come out for x1 will be 7.12. Okay? Then try to compute for y1 is 8.12. So actually, the first intersection is at the location 7.12 and 8.12. It is this one. This is 7.12. This is 8.12. Okay, the coordinates of this one is 7.12 and 8.12. The next one, since this is a quadratic equation, there will be two values of x. So actually, after the substitution of y equal to x plus 1 back here, the second value of x is actually 2.88. Okay, and y sub 2, we bring it back here, it will be plus 1, so that will be y2 will be 3.88. So the coordinates of the second intersection is at the location 2.88 and 3.88. It is this. 2.88, 3.88. Okay? Okay, let's proceed with the so-called, we drew now the hollow circular washer method. We drew, what is required is actually the volume of the upper area bounded by the circle and the straight line. Okay, I will try to place the bound, it should be the area covered by the red one. Yeah. The problem is asking such that if we try to rotate by the upper area bounded by the circle and the straight line, one complete revolution with respect to the x-axis, what is the required volume? What is the volume? That's the problem. So, okay, so let's try to rotate now. What will come out on the isometric view will be something like this. It's a circular washer, hollow circular washer. Okay? This is y lower, this is y higher, and the thickness is dx. On the vertical slice, this point here is y lower. The one on top is actually y higher. So actually the vertical height, or the vertical height is actually y higher minus y lower. That's the net radius. So if we now try to bring out the differential volume for a circular washer will be pi times the quantity y higher minus y lower quantity square. Okay guys, I will tell you where I made the mistake yesterday. Okay, we are just human, okay? I forgot these two here yesterday. I forgot to square this one. I forgot this one. Okay? I forgot that one. So all along up here, my solution is wrong. Okay? Sorry for that one, we are just human. And I am now correcting that error. That's why I erased that video. Okay? For those who are smart enough to have followed this step by step, you could have seen that I forgot the two over here. Okay? Because the differential volume is actually pi radius square times the thickness. Okay? It is y higher minus y lower. Y higher is actually the ordinate of the circle, and we could take the value of y higher to be equal to this. You get it from the equation of the circle. Simplify this one, compute for y, okay? Y higher will be 6 plus the square root of 9 minus the quantity x minus 5 quantity square. And y lower is actually the ordinate of the straight line. It's easy. Y is equal to x plus 1. So actually y lower is actually x plus 1. So what do? We substitute y lower and y higher back here. Okay? Then try to square it. My mistake yesterday, it was a human mistake. I forgot the 2. Okay? I will not show you the simplification now. It is very long a little bit, and after expanding this one, what will come out is this one. This is correct because I used the longhand method in solving this one. I got this. If I will place this one, the board will not be enough. Okay? Therefore, this is differential volume, guys. Then to compute for the volume, try now to integrate. Okay? And what will be our limit? Our differential thickness is actually dx, right? So dx should move from 2.88 to 7.12. So actually the limits are actually, the right hand side will be the limit 2.88 to 7.12. That's the significance of the solution of the solving the intersection. Okay? And if we try to integrate this one, this should be 9x. Okay? The integral of this, guys, it falls under the power formula. I expanded, I check it. The value of u, if you try to differentiate this one, what will come out for the total differential is 2 times the quantity 5 minus x times the x. It is exact. So what will come out will be 2/3. This is over 3/2. Then we try to take the reciprocal. This will be 2/3. It is same. The value of u inside is this, raised to the 3/2. Because 1/2 plus 1 is 3/2. Actually, this is all over 2/3. I simplify it already. So volume is actually pi times the quantity 9x plus 2/3. This quantity here raised to the 3/2 with the limit from 2.88 to 7.12. It's a long, tedious solution because what you will do is that take the upper limit, place it here, then compute for the value. Use your calculator, guys. Use your calculator. I did it myself. If I place 7.12 back here, then take the simplification, the value is actually 70.44. Okay? Is it correct? Yeah, 70.44. And if we place the lower limit 2.88 back here, what will come out is 2.88. Okay? The volume now will be the value of the lower limit when substituted minus the value of the lower limit when substituted. Higher limit value minus lower limit value, 70.44 minus 32.28. The volume is actually 38.16 cubic units. 38.16 cubic units. It was way away from the answer yesterday because yesterday I forgot the 2 over here. Okay? And now I didn't forget the 2. Okay? Because differential volume for a washer is actually pi times radius quantity square times thickness. I forgot the 2 yesterday. Sorry for that one. We are just human. I must have to remove that video because it was very wrong up to this point here. Okay? There was nothing wrong with the solution except that I forgot the 2 to square it. Okay guys, that's the importance of the topic this afternoon. It's the so-called hollow circular washer method, an application problem. there is a hole from this point here with respect to the axis of rotation. So actually the washer is it got a hole at the middle, you know. It's a circular washer, right? Okay, good afternoon, Los Angeles.